Hello friends, welcome to Ccna video series lecture number 9. Topic of this lecture is IP version 4 subnetting of class A from /16 to /30. In previous lecture, we subnetted class A network up to /13. In this video, we will subnet class A network up to /30. As far we have come together, you must know that for subnetting we have to borrow host bits, so let's borrow 8 bits from second octet. New subnet mask will be 255.255.0.0 because if we add the spot values of borrowed bits, we get 255. New CIDR value will be /16. The number of subnets will be 2 raised to power 8 because we have borrowed 8 bits and that will be equal to 256. So we will get 256 subnets starting from 0 to 255. Number of hosts per subnet will be equal to 2 raised to power 16 because there are 16 bits left in the host segment, and that will be equal to 65,536. One for the subnetwork ID and other for the broadcast address. So our valid hosts per subnet will be 65,534. The block size of the subnetwork will be 256 minus 255. That will be equal to 1 for second octet. 256 minus 256 equals to 0 for third octet and 0 for the fourth octet because we did not borrow any bit from third and fourth octets. So the block size we get is 1.0.0. Based on the values we got, let's generate our table of subnetting. The first subnetwork ID will be 0.0.0. Then we will keep adding the block size of 1.0.0 in the previous subnet ID until we get 255.0.0. Now let's find broadcast address of each subnetwork. Broadcast address is all the host bits turned on. Since there is no bit left for the host segment in second octet, so it will be 0, and in third octet all 8 bits are for host segment. So by adding their spot values we get 255. Similarly, in fourth octet all 8 bits are for host IDs. So by adding their spot values we get 255. So we get 0.255.255 as the broadcast address. By adding 0.255.255 in each subnet ID, we will get broadcast address of each subnet. For example, if we add 0.255.255 in 1.0.0 network, we get 1.255.255. Similarly, if we add 0.255.255 in 3.0.0 network, we get 3.255.255 as the broadcast address. To find the first valid host, add 1 in each subnet ID. So first valid host of each subnet ID will be 0.0.1 and 1.0.1 and so on. To find last valid host, subtract 1 from broadcast address of each subnet. So the last valid host of 0.0.0 subnet will be 0.255.254 and 1.255.254 for 1.0.0 subnet all the way up to 255.255.254. Hence, we have completed subnetting of class A up to /16. Now let's borrow 2 bits from third octet and let's see what we get. New subnet mask will be 255.255.192.0 and CIDR value will be /18. Note that 255 and 192 is the sum of spot values of borrowed bits. Number of subnets will be 2 raised to power 10 because we have borrowed 10 bits, which is equal to 1024, and number of hosts per subnet will be 2 raised to power 14 since 14 bits are left for host segment, which is equal to 16,384, and after subtracting 2 we get 16,382 valid hosts for each subnet. Note that we are getting block size of 1 from second octet, 64 from third and 0 from fourth octet. Since we have borrowed 2 bits from third octet, so by raising the power of 2 to 2, we get 4 subnets in third octet for each value of second octet. We will get 4 subnets if, for example, first subnet is 0.0.0, so by adding 64 in third octet, resulting subnets will be 0.0.0, 0.64.0, 0.128.0, 0.192.0, and the next value will be 0.256.0, which is not valid, so we will remove 0.256.0. Hence we got 4 subnets for 0 value of second octet. Now by adding 1 in second octet, new subnet will be 1.0.0. As you can see in this subnet, the value of second octet is 1 and we have to get 4 subnets for it. So we will add 64 again in third octet. Next subnets will be 1.64.0, 1.128.0, 1.192.0, and that's it. We got 4 subnet values in third octet for the value of 1 in second octet. Now repeat the same process for 2.0.0 all the way up to 255.0.0. Now let's find broadcast address of each subnetwork. Broadcast address is all the host bits turned on. Since there are no bits left for the host segment in second octet, so its value will be 0. There are 6 bits available for host segment in third octet, so by adding their spot values, we get 63. And in fourth octet, 8 bits are available for host segment, so by adding their spot values, we get 255. Hence we get 0.63.255, and by adding it in each subnet ID, we get 0.63.255 as the broadcast address for 0.0.0 network and 0.127.255 for 0.64.0 subnet, and so on. To find the first valid host, add 1 in each subnet ID. So first valid host of each subnet ID will be 0.0.1, 0.64.1, 0.128.1, and so on. To find last valid host, subtract 1 from broadcast address of each subnet. So we get 0.63.254, 0.127.254, 0.191.254, and so on as the last valid host of each subnet ID. Hence we have subnetted class A network up to /18. If you have any question or confusion regarding this lecture, do comment and I will try to explain it in the next video. In the next video, we will start subnetting class A network up to /30. Thanks for watching. If you like the video, please subscribe to my channel and press the bell icon to get regular updates about upcoming educational videos. Thanks.